Hey everyone, welcome back to the channel. Today we are solving a fascinating string manipulation problem, finding starting indices of concatenated substrings. This problem is one of those that combines string searching, permutation, and sliding window techniques all into one. I'll break down the problem, share a bit of my own experience solving it, and then walk you through a C-sharp solution line by line. Let's get started. Here's the problem. We are given a string S and an array of string called words. All the string in words are of the same length. We need to find all starting indices of S where the substring is a concatenation of all the strings in words in any order. Each word must be used exactly once. For example, if string S is equal to this and word equal to foo bar, the answer is 0, 9 because the substring starts at index 0, foo bar foo, and index 9 is foo bar, or concatenation of foo and bar in the array. Pretty cool, right? On the other hand, if S is equal to this and word equal to word, good, bashed word, there is no valid substring, so the output is an empty string. When I first tried solving this, my instinct was to generate all permutations of words and check if they appeared as substring. But as you might guess, that approach didn't scale well with larger inputs. Then I realized the power of using sliding window combined with a frequency map to keep track of the words efficiently. It's a great example of thinking algorithmically can solve and simplify complex problems. Here's the plan. Use a dictionary to store the frequency of each word in words. Use a sliding window of size equal to the word total length of all words combined. For each starting point in S, check if the substring matches the concatenation of all words by comparing word frequencies. This approach ensures that we're not redundantly generating permutations or rechecking the same substring multiple times. Let's implement this in C#. I'll walk you through each step as we code it. Let's break this down step by step. We define a method find string that takes a string S and an array of string words. It returns a list of integers representing the starting indices of valid substrings. We create a result to store the indices of valid substring. If either word of or S is empty, we return an empty list immediately. Next, we calculate two important values: word length, the length of each word in words; total words length, the combined length of all the words. This defines the size of our sliding window. We create a dictionary word count to store the frequency of each word in words. This will help us efficiently check if the word in the substring matches the required count. Now we loop through all possible starting indices of substring in S. We stop at s.length minus word total words length because any substring beyond that won't have enough characters to match that word. We use another dictionary, seen words, to keep track of the words we have encountered in the current sliding window. The nested while loop processes the substrings word by word. Inside the while loop, we extract the next word length from the string. If the word isn't in our word count, it's not part of the words. So we break out of the loop. If the word is valid, we update its count in seen words. But if its count in seen word exceeds its count in the word count, the substring is invalid and we break out. If we successfully processes all the words in words, that is j equal to words.length, we have found a valid substring. So we start at the starting indices I to our result list. Finally, we return the list of starting indices. This concludes our algorithm. To sum it up, this problem can feel a bit tricky at first, but breaking it down into smaller steps like building a frequency map and using a sliding window can make it much more manageable. By focusing on efficiency, we reduce the time complexity significantly compared to brute forcing all permutations. Personally, solving problems like this has helped me to see the values of combining different techniques like frequency maps and sliding windows to solve complex challenges. Alright, that's it for today's video. If you found this tutorial helpful, please give it a thumbs up, subscribe and hit the bell icon so you don't miss any future contents. And let me know in the comments if there's any another problem that you'd like me to cover next. Thank you for watching and happy coding.